Alright, so last session we looked at fractions and we managed to complete most of what we intended to complete for that session. Now for this session we want to start off by looking at or continuing with the order of operations. So from the last session the representation of this was done using pemdas. So you can remember what they stand for.
Parentheses, exponent, multiplication, division, addition, subtraction.
That's spelling it wrong. Exponents, multiplication, division, addition, subtraction. So what did we say about the multiplication and division?
They're the same.
So these are on the same level, so we do them as or in the order that they appear. And the same goes for addition and subtraction. Alright, so we want to jump straight into some questions. So these are just some warm-up questions. There's nothing much to order of operations. You just need to identify what is the, especially in the basic parts of this when we're dealing with just numbers, no algebraic terms or anything like that. So questions, and we're going to be going through all of these together. So the first one, we have 4 times 8 minus 7 times 6. What do we do first?
So the 4 times 8?
So 4 times 8, that gives us
32.
what next?
Then we go to 7 times 6.
That gives us
42. Then you subtract that.
the answer is
Negative 10.
negative 10. Alright, that's an easy one. So this one now is half times 12 plus 6 minus 4. What do we do first? What do we do second, third, and so on?
Do the bracket first, then multiplication, then subtraction.
So we do this first. So 12 plus 6, that's 18. Then we do this after. Half times 18.
9.
So this is 9 minus 4. That's equal to 5. Pretty straightforward, right?
Yes, sir.
How about this one? Half times 23 minus 9 plus quarter times 15 minus 7. What do we do first, second, third, fourth, and so on?
Brackets, then multiplication.
Which one of them?
Can we do any one of them?
Sure.
The first bracket, then the second bracket. Then
So-
I do the first multiplication, then the second multiplication.
So 23 minus 9.
14.
And 15 minus 7.
8.
So this is half times 14 plus a quarter times 8. So then you said we do multiplication next. So this is 7 plus 2 equal to 9. Is that clear?
Sorry, don't delete it yet.
Alright, so those are pretty easy. But how about this one? We have 3 squared minus 7 times 2 squared plus 8 squared. What's happening here now?
Sir, we're going to do the first bracket first, the 3 is being squared by the 2, then you subtract it from the 7, and then after that you figure out what's happening in the second bracket, then you multiply it by 2.
So in the first bracket, what would that give us?
Positive 2. 9 minus 7.
So this is 9 minus 7.
So, excuse me, sir.
Yes.
How you get 9, we get 2.
Because right here is 9. You did all of this on the calculator, right? Like everything in one.
Yes, sir.
Well, we'd still get 2 in the next step.
Okay.
So this bracket would give us 4 plus 8 all squared. So now this is 2 times 12 squared. And 12 squared is what?
144.
288. So we don't have much to worry about with order of operations. We just need to look at what's there first and as it relates to the order in which we work here. So we go from the P all the way down to the S. The trouble will come when we get to transposition and we need to perform the opposite operation, but we'll get there shortly. Alright, so next on the agenda we have decimal places and significant figures. Now, this is everyone's favorite topic. Alright, let me write a number here. Let's say we have 1.27345. And I ask you, how many decimal places are there in this number? What would your answer be?
5.
How did you get 5? So we have 5 different numbers after the decimal point. So this would have 5 decimal places. Is that clear?
Yes.
So how many significant figures would we say this number have? How many significant figures? How many significant figures does this number have?
Sir, is what I mean? Figure like when you have the dance and ten something.
No, significant figures are those figures that we look at a number and they make the number significant. It makes the number make sense.
True.
So if we're looking at this number, how many of these figures make the number make sense?
One.
One number make this number make sense.
Two.
No. All of the numbers are significant here.
Oh, sir.
We don't have any zeros, and all non-zero numbers are significant. So there are 6 digits here. So there will be 6 significant figures. We'll get to the table with the rules shortly, but there are some rules that governs significant figures. But all non-zero, numbers, digits are significant.
So what is like? Replace the 3 with a 0 with the 4 and 5 so this is significant.
If we replace the 3 with a 0 here,
Yes, sir.
yes, they would. And even this 0 here would now be significant because it falls between two significant figures. So there are a few rules that govern significant figures, and we will be getting through them shortly. Alright, so
Is a new topic this?
yes, decimals and significant figures. So let's say we had 7/8, and we were instructed to round the answer to 2 decimal places. Firstly, what is 7/8 as a decimal?
0.875.
So 7/8 as a decimal is the same thing as 0.875. So we want to round this off to 2 decimal places. So what we do is, so this is the decimal point. This would be the first decimal place, second decimal place, third decimal place. What we want is the second decimal place. However, we can't just erase the 5 and say, okay, 0.87 is our answer. There's a rule also that governs rounding off decimals or even rounding off numbers. So the 7 here, we need to look at the number that is to the right of the 7. So this number is 5. So we can increase the 7 by 1. If this number is 4 or less, we would just leave it as 0.87. So the rule is that, so this would be 3 decimal places, like overall. Alright, so I have 3 decimal places in the number. The 7 here is in the second decimal position. The 7 right here. So what we do is we identify the position we want. Then we look at the digit that comes after. And lastly, this is the rule that we follow. If the number, so this goes for the digit that comes after. So if the number is 5 to 9, we round up. If it is 0 to 4, we leave the digit. Pretty straightforward, right? All right. All right, let's see.
So what is in the red? Can you read it, please?
If the number is 5 to 9, we round up. If the number is 0 to 4, we leave the digit. Let me say as is. This will be sent to you, Kai, after.
So I can't really understand the rest.
But this is how I write on the board.
So I write better than this.
Kai. Alright, so let's consider the number pi. We know that number, right?
Yes, sir.
What are the digits of pi?
3.14.
No. 1, 5, 9, 2, 6, 5, 4, and so on and so forth. Alright, so let's say,
Sir, I only know 3.14.
and this number goes on to infinity. So let's say we wanted to round this to 3 decimal places, and we normally use dp. We want to round this to 1 dp, 5 dp, 6, 7. Alright, so rounding off pi to 3 decimal places would give us what?
Sir, repeat.
Rounding off pi to 3 decimal places would give us what?
3.142.
So we look at what's in the third position, then we look at the number after it, 5 or more, we'll just increase that by 1. 1 decimal place,
3.1.
5 decimal places,
3.1416.
5 decimal places, 3.141,
5.
5, 9,
9.
6 decimal places,
3.14159. 3.
and 7.
3.141592. 7.
And that's how we do it. We simply look at what's in that position that we want to round off to. We look at the number that comes after. If it is 5 or more, we round up by 1. If it is 0 to 4, we just drop off that at that point. And that should be pretty straightforward, right? What about this? Let's say we had the number 2.69897.9. Let's put another 9 for good measures. And let's say the examiner wanted us to give them 2 decimal places.
Would it be 2.70?
2.70. Now, how does this work? Why does this happen?
So because when you round up the 9 by 1, it would give you 10. So I guess you would round up the 6 to 7 and add the 0 into 2 decimal places.
So we look at this, what's in the second decimal position, which is the 9. Then we look at the number after it. So the number that comes after it is an 8. So if we were to round this up from 9, it would now become a 10. However, we can't have 2.610, whatever that is. We have to bring over the 1 here. So it's like addition, and you're carrying over the next group of numbers. So that's why we get the 0, and then the 1 will be added to the 6 to give us the 7. What if they had asked us to round this off to, let's see, 1, 2, 3, 4 decimal places?
2 point. So it would be 2.7090.
7090.
2.6990. Because it's 7 to the 9, 10, 0, I don't, 9. So would it be 2.6990?
So it's 2.6990.
Sir, I'm confused.
Alright, so 4 decimal places. We look at what's in the 4th decimal position, which is this 9, right?
Yes, sir.
And then we look at the number that comes after it. So if the number is 5 or more, we would have to round up this 9. So if we round up the 9, we're going to get 10. But as stated, we can't just put 10 here, so we have to put the 0 and carry over the 1. So this 1 will be added to the 8. So it now becomes 2.6990. And that's how we do it.
Okay.
So what if we wanted to do... Alright, that one won't change it much. Let me do one last example of this. Then we'll look at some significant figures. Alright, so let's say our number is 19.99999, and your evil examiner wanted you to give them 3 decimal places from this. Let's see.
20.000.
So you look at what's in the 3rd decimal position, look at what comes after it, so you'd add 1 to this, we'd get 10. So it's 20.000, right?
Sorry, me not follow along. I am very confused.
Same concept, Kai. We look at the 3rd decimal position, we look at the number that comes after, which is the 9. So we're going to have to add 1 to this 9. That's going to give us 10. However, we can't just leave the 10 up here. We have to put the 0 and carry over the 1, right?
Yes, sir.
So when I carry over the 1 here, so now we have a 1 plus 9. That's going to give us a 10 again. So the same process repeats. We can't leave a 10 here, so I have to put the 0, carry over the 1. Same process. 1 plus 9 gives us 10. Put the 0, carry over the 1. 1 plus 9 gives us 10. We put the 0, carry over the 1. So that's how we get the 1 plus 1 would give us the 2 at the front. And that's 20.000.
Oh, okay, sir.
And I know someone might say, isn't that just 20? Yes, it is just 20. But we asked for 3 decimal places, so these are a must to be included. And that's the approach we would take when rounding off. Any other questions on this?
I don't think so.
Alright, good. So now let's look at some significant figures. Seeing that you guys haven't done that since first form, I believe. Right?
If we even do it in a first form.
Alright, so significant figures. Alright, so let me do up a table here on how we can operate with these things here. Alright, that should be fine. Right, so there are a few rules that governs significant figures, and we'll be looking at all of those rules, because as you know, this is something that is tested on a yearly basis on your CSEC exams. So the heading for this, or the is counting significant figures. And then over here we're going to have some examples. Alright, so the first rule that governs significant figures would be that all non-zero digits are always significant. Alright, so that's all non-zero digits are always significant. So if we have something like 1.54 or 45, how many significant figures does this one have and this one?
Two.
This one have two?
Two.
It's 1.54, you know. Let me put it a little closer. It's 1 point. So that one has 3 significant figures. And we refer to it as sig figs. And this one has 2 significant figures. So let's look at the non-zero digits here, and that would give us the answer. So the next rule is that interior zeros. What do you mean by interior?
Inside. Between two significant figures.
So zeros between non-zero numbers are significant. So for example, we have something like this, 0.02503. How many significant figures are there in this number?
Three.
What are the 3 significant? Okay, 4. So all non-zero digits are significant, and then the zeros that fall between non-zero digits would be significant as well. These ones at the front, they don't count as significant figures. So this number has 4 significant figures. Alright, how about this number? 3.00674. How many significant figures are there?
4. 4.
Sure?
6. Yes, sir. Yeah.
What are the 4 significant figures?
3, 6, 7, 4.
So what about those the zeros between non-zero digits? Aren't these zeros? Aren't these non-zero digits? And we have zeros between them.
Yes, sir.
So we have 6 significant figures. So as long as it's between, so even if we have 9 0 0 0 0 0 1, these zeros are between, so they would count.
Oh, so if the 0 is at the end, it won't count.
No. There are only one condition, but we'll get there shortly. A special condition for that one. Alright, so the next leading zeros so these are zeros at the beginning of a number are not significant. Which color can I use here? Beginning of a number not significant. So for example, we have 0.103. How many significant figures do we have here?
3.
So we have 3 significant figures. And how about this one? 0.00002. So is that making sense now?
Yes, sir.
So the last condition would be, so we have non-zero digits, we have zeros in between non-zero digits, we have leading zeros. So what do you think the last condition is?
Behind zeros.
So those would be the trailing zeros. So these are the conditions for those. So zeros at the end of a number are significant if and only if there is a decimal point present in the number. That's the only condition. Otherwise, they would not be significant. Alright, so let's see. So if we have 1.050, how many significant figures are here?
4. Huh?
So remember, zeros that comes after are only significant if there's a decimal point. Because decimal points are used to express, what do I say, accuracy or precision. So usually when you see a decimal point, we're dealing with precision and we don't want to leave off anything from a number that is precise. What about 1000?
1.
And then we have 190.
2.
Two significant figures. All right. So that's how we approach counting significant figures. So we can look at rounding off to various significant figures. So we do a few questions like that, and then we can look at transposition. Are we good with directed numbers?
I don't know what that is.
Of course you know what it is. You know how to do this, right?
Yes, sir.
That's directed numbers. Or even this. We know how to do that?
Yes, sir.
That's directed numbers. So it's just operations involving additions and subtractions. But usually it would be where the signs can fall between. So we can have it like this, or we can have it like this, or -8 plus 5, 8 minus 5. So we can have it like any of these, and I'm pretty sure we can do all of these. First one is what? Right here. 13. This one is
-2.
this one,
-13.
and that one is 3. So we will skip past directed numbers and go into transposition after we do a few of these significant figures. Alright, so we know we can get decimals to give the answer as, well, not decimal, fractions to give the answers as significant figures. We can get multiplications of decimals to give the answer as significant figures, addition, subtraction, and so on. Alright. Let's look at an example. So let's say we wanted the product of 5.02 and 89.665 and 0.10. So we needed to find the product of these three numbers. What would our answer be? Forty-five point 0.1183. Now let's say we wanted to round this off to, so round it off to two significant figures. Then we want to round it off to 4 significant figures, and then let's say 3. to two significant figures, what would this number be? To two significant figures?
Yes. 45.
Just 45.
45.
So we're looking at the first. So significant figures start from the left going right. So this is the first, second, third, fourth, fifth, sixth, seven, and that way. So if we want to round off the two significant figures, we'd have to do it the same way as how we would round off decimals. So we look at the 5 here, then we look at what comes after it. It's a 0, we just drop everything over here, so it would just be 45. How about 4 significant figures?
45.01.
And then 3 significant figures.
45.00.
0. And remember, trailing zeros are only significant if there's a decimal point. Or, yeah, if there's a decimal point. The other 0 is the one that falls between 2 and 0. Alright, let's try another one. Let's say we had 5.892 divided by 6.10, and we wanted this answer to 3 significant figures. So give me the answer to 3 significant figures.
So 1.00.
1. You get 1.
But the answer I got was 0.965901639.
So this is equal to 0
965
0.965
901
901.
6293.
Alright, so that's the number we got. So we want 3 significant figures. So we count off where the third significant figure is. And that would be what?
965. 0.965.
So the 5 here would be the third significant figure, right?
Yes, sir.
So what's the number that comes after it?
9.
9. So this 9 is greater than 5, so we round up. That's what we always did, we round off. Even around, where was it? Up here, we round off. The reason why we didn't round up for the top question was that the numbers are less than 5.
Oh, okay.
Alright, so you know the examiner won't give you strictly these to calculate and say round after that, round after that. What they will do is they will give you something like this: 7 and 1 over 7 times 5 and 1 over 5 minus 3 and 1 over 3, and then they will say Firstly, they will say give an exact answer. And you know what we mean by exact answer, right?
Decimal.
No.
A fraction. Fraction.
So we're working with a fraction, so we leave our answer as a fraction. Then we want 3 significant figures, and then we want 2 decimal places. So I'm going to give you 5 minutes to try this one. So I'm giving you 5 minutes to try this one. And then we can start looking at the next topic, if there are no other questions about significant figures. So who will be walking me through this question? Shaniqua?
Oh.
Simple fractions.
Can you put this time? Sorry. Probably after we're done this, I'll help you with the next one.
Alright. Who else do we have here? Nikandra, still here? No. Tori? We want a walkthrough of this question. Alright, so what did you get when you put everything in the calculator?
I got 710 over 21.
Okay.
Sir,
Yes?
my calculator is jumping straight into a decimal.
That means you probably need to reset it or something.
Sir Doyle,
Yes?
I got 551 over 105.
You put everything in there just the same as is?
Yes, sir.
Alright, let's see. So we have 7 and 1 over 7 times 5 and 1 over 5 minus 3. So the answer is 7 10 over 21. Let's see what that would be as a...
Let me get this.
So it's 33 and 17 over 21 as a mixed fraction. So we could leave this as... So for the first part, we can leave this as 710 over 21. You'd still get your answer. Or 33 and 17 over 21. You'd get your answer. Get your mark, be on your way. So the next part says...
My calculator doesn't give me that. What am I supposed to do?
Double check what you put in the calculator. Because maybe... How did you put this part in the calculator? The 7 and 1 over 7. Did you write it like this? Well, let me get the decimal first. So this is 33.8015. No, Kai's calculator is very good.
Is that Casio? Yes. So remember, say my fraction no look like here no more.
Alright, so reset the calculator.
So you know to do that.
Look on the calculator if you see a button that has CLR above it. So it's above the 9 here, so check your calculator if you have a CLR button. If not, I'll fix it for you tomorrow.
Okay, sir.
Alright, so as a decimal, well, they want 3 significant figures. So to 3 significant figures, this would be what?
33.8.
So we look at what's in the third significant position, what the number that comes after it. That's not significant to us in this case, so it's just 33.8. Lastly,
Sir, in CSEC, are they gonna have a section for significant figures?
so it would come, the question would come something like this. So you get the fraction, then they would ask you to probably leave it in the exact form, 3 significant figures, 2 decimal place, and so on. Write it out as a standard form or something like that.
Okay. Sir, I fixed it and it's still not working.
When you're putting in the fraction, Kai, change them to improper fraction. So this one would be 50 over 7, 26 over 5, and 10 over 3. So change them to improper fractions when you're doing it.
Okay, sir.
Alright, so now to 2 decimal places, what would our answer be?
33.81.
So we just look at what's in the second decimal position, we look at the number that comes after it, then we just round that up. It's that simple. Alright. So do we have any questions on significant figures or decimal places? So no questions?